My name is Alex Shalaev, and in this short video, I would like to explore the Spring Native project for Spring applications and compiling them to GraalVM native images to the platform binary. I would like to see how small I can get of an application and how small the Docker image for the container will be for that application and how fast they start. So let's get started. Spring Native is, of course, the project that provides support for compiling Spring applications using the GraalVM native image technology. And recently, with the 0.9 release, it got into the start.spring.io, so you can use it for project generated in here. Let's start and explore that on a small application. We're going to pick the Maven project and Java. We're going to pick the Spring Boot 2.4.4. And I have pre-filled my group ID and artifacts ID with the primes, because my microservice will be running on the primes numbers. Now, what I can do, I can add the dependencies here, and you can see that the Spring Native project is one of the dependencies that you can add from the start.spring.io. Since we're building the web application, let's add some web stack as well. So now I can generate this project and it will download the archive for me, and I can start working on that project in my IDE. I have already uploaded the primes zip archive to my cloud machine where I'm gonna do the development. So let's just unzip that. And you can see that it generates a sample project for us. Let's import that into our IDE and see how it works from there. So we're gonna specify the file there. So we go primes zip, primes spring, our folder, pom.xml, open as a project. And while it's importing, let's make everything a little bit larger. So one cool thing to notice about the Spring Native, that it generates the help MD file, which links the relevant resources and also for the Spring Native as well. So it helps, it lists helpful commands and it shows you how to get started. So we will do a very simple test here. So let's just see the Spring application. It's very simple. It's a normal application. So let's fill it with a sample functionality. So we'll just do the new class, new Java class, and we'll say the primes controller just to specify the basic functionality. I have it here. Let's just import everything. Let's just import everything. The imports, the IDE knows very well. Import class, import class, import class. Right. So the functionality of this app, just import everything. Right. We've imported everything. The functionality is very simple. We can compute the prime numbers, and we're gonna respond to the query on the URL primes random and giving the upper bound. We're gonna return a prime number, a sequence of the prime numbers. It's a very simple application, and the functionality is very sample here. So it will generate some pressure on the memory because we compute the prime numbers using the streams API. So we box the integers, and it's not a very efficient implementation, but that is beyond the point of this video. It generates some pressure on GC and it generates some CPU cycles. So that is sufficient for the sample application. Now, to compile this with the native image to the platform binary, there are two ways. You can use the build packs, and the definition is there in the application. So you can see that the Spring Boot Maven plugin uses the build packs, or you can build it on your machine, and that's what I would do. I have this machine with the GraalVM installed, so I will use the current GraalVM on my machine, and for that I need to enable the native image plugin for the Maven. I will paste the configuration here, and let's look at that in a little bit more detail. So we create a special profile called native image, and we say that we're gonna use, in that profile, we're gonna use the native image Maven plugin of recent version, and we're gonna specify the main class, and you can also specify the custom arguments for the native image process. So it will happen on the build, on the package phase. That's when native image will package our application. What else we see here is that there is the Spring Boot Maven plugin, which we need to configure I think we need to configure the phase execution here. I think that's written in the docs. Let me just double check. Spring Native plugins, quick start, check the documentation. The documentation is quite extensive. Let's get started. Maven plugin, sample project setup, add Spring Native, Spring IoT transformation, enable support. Yes, so for the Spring Boot Maven plugin, we need to add the classifier for the configuration because both of them want to run on the package. So not to confuse things, we want to add the configuration. We want to add the configuration, the classifier here, right? So now we don't have that confused. And the important part here is also the Spring IoT Maven plugin, which will pre-compute the configuration for our application based on the class paths during the build, and it will generate some classes that will simplify working with the native image compilation and will pre-configure your application. So you can also configure that. And we will configure that to remove the some support for unnecessary features that we have here. So we'll remove the spell support and we remove the YAML support from the application because we know that our primes computation do not need that. So what we can do now, we can of course run this application. So we take that from the functionality, Spring Native documentation. Let's get back to the get started build using Maven plugin. We need to run the command, which is the here, Maven native image package. I could have remembered that. So we run Maven, we specify the profile, and we say that we want to package this. This will take now a moment because we need to build our application, and we also need to compile that to the platform binary using the native image command. That will take something like a minute, or maybe a little bit more. We're also building the statically linked executable with the muscle C based libc. So it gets linked into our application, so we can use that in a much smaller Docker image. While this process is running, we can prepare the Docker file for our deployment. So we're gonna create a new file called Docker file, and we're gonna do a very simple thing. So we're gonna say that we want from scratch. That would be our base image. Since we are linking everything statically, we don't need anything more. We're gonna copy the file, which I assume supposed to happen, become like that, supposed to be the result of our packaging here, to the container under the app, and then we specify the entry point, which is also that single file. So this is our Docker file, and we gonna build the Docker container, Docker image, and run the Docker container based on that. So in the from scratch Docker image, there is nothing. So the only thing inside that Docker container is our application, which is supposed to be very good for security because the code that is not there cannot be exploited. We're very close to finishing the compilation here. You can see that the native image process is running. It creates the closed universe of all the classes that will ever be executed in our app. It builds the universe of the objects, and then it analyzes that, inlines the code, and then compiles the code to the binary. Let's wait just a few more seconds while it works. The larger phases here are the analysis and the compilation, and the GraalVM team is working on both to speed them up, but currently it does take, 2 minutes for this small application. Let's see if this application actually happens to be where I expect it to be. It does, and you can see it starts really fast in like 50 milliseconds, and it is available here. If we go to the primes controller, let's see if this Let's see if this application now responds. So I will open the HTTP client and I will run this request against the local host. We of course need to provide some configuration here. So let's say we're gonna do up to 100 things and then run that, and we get the response back, and you can see that we get also the prime numbers back. We can also run it again. So our application is functional, our application is working, our Spring Boot microservice returning the prime numbers is compiled to the native image to the small platform binary. Let's see how big it is. So let's stop this application and let's see what's the size of that. So it was target and it was org this long pass. So it's 60 megabytes. What I can do now, I can use the UPX universal packager and say that I would like to compress my executable and I would like to keep the original for the backup as a backup, right? And I give the pass to the executable. So now this packager will try to compress my executable using several algorithms, and then it will output the best solution that we have. The -7 is the key up to which compression algorithm to go. There are a number of things that you can try there, but it packages your application, becomes smaller. But if it uses very heavy compression techniques, then the startup of the application can become a little bit higher because you need to uncompress the application. So after this build has finished, it will produce the executable on the same path here, and we will see how much what's the size of that executable then. I suppose that it will be much smaller, right? So you can see that the compression ratio is now the application takes only 30% of what it took previously. So if we do the ls again, you can see that now that executable is 19 megabytes, and we can still run it, right? Target work this application. This application still starts really fast, and it still runs the same way. Let's build it and put it in a Docker container now, right? So we need to do Docker build. We can do the file, Docker file, and we will tag the image. We'll say primes Spring, and we're gonna do Scratch because it's the container from Scratch, and we say here. Now building the Docker image is very simple here, because there are just a few commands, and we literally just copy this application, which is 19 megabytes large, and we can do Docker images now and see that there is this on the very top. We can see prime Spring from Scratch takes 19.9 megabytes in size, and we can run this. So if we did Docker run, we want to remove the container after we use it. We want to open the ports 8080:8080, and we do primes Spring Scratch, and we can run it. So Docker runs this application. It still starts like really fast, and we can still run the requests here. You can see that the following requests succeed, and it prints us prime numbers under 100, a sequence of those, and you can see that it all works. So that's how you can do it. You can run the Spring native project, and you can use that help to compile your Spring applications using the GraalVM native image technology, and you get a very small executables. So and they start really fast, which is really good for deployment into cloud environments where the startup and the memory consumption are important qualities of the runtime performance profile of your application. If you have any questions, leave them in the comments below, and until next time, thank you.